So we're going to today discover the life and science of sharks and rays. It is lesson 4 this time. When most people hear the word shark, they imagine of sharp teeth and fins slicing through the water instantly, and it comes to mind. Indeed, sharks include some of the most planet's efficient killers. They are powerful hunters and able to catch fascinating things, even from 1,000-pound tuna, small whales, and occasionally even people. But as nature shows, not all sharks are murderous killing machines. So sharks fall in the classification of silky, and rays, skates, and sawfish fall in the group of Batodidae. Classification. So we have got the class, subclass, order, and as we can see the brackets show extra information. So class of Chondrichthyes, or again Siliki, are cartilaginous fish. So cartilaginous fish are nothing that because they lack true bone except in the roots of their teeth. Gills clefts 5 to 7 in Siliki, and 5 gill openings occur on the lower surface of Batodidae, and only 1 in Chemiforms. Dorsal fins and fin spines rigid, not erectile if present, approximately 940 species. Subclass is Elasmobranchi. So Chondrichthyes with 5 to 7 pairs of gills, cleft not covered by a fold of skin, opening separately to an exterior. Order Siliki, again sharks. As we know, there are more than 400 species, and they have with gill clefts opening at least partly on the side of the body. Order Batodidae, as we said, is rays, sawfish, guitarfish, skates, and stingrays. So there are 5 gill openings, woolly on ventral surfaces, pectoral fins united with sides of the head, forward past the gill opening, differ from all sharks in lacking the upper free eyelid, and more than 500 species, Jurassic to present. Subclass Halocephali. Jaws are holistic, which means they support the upper jaw completely fused to the cranium. Hyoid arc complete, unmodified branchial arches below cranium, internal skeletons of cartilage, often calcified but never of bone. Dermal skeletons of dentin or dentine-like tissue. Never with true bone, scales do not continue to grow once fully formed. Pelvic and cephalic claspers in males of some groups, and there are about 40 species. So subclass of cartilage fish includes, as we said, the whole species. Order is Chlamybranchi. Sharks and rays fall in the different groups. So it is a subclass that includes the sharks and rays and skates. Members of the Elasmobranchi have no swim bladders, 5 to 7 pairs of gill clefts opening individually to the exterior, rigid dorsal fins, and small placoid scales. The teeth are in several series. The upper jaw is not fused to the cranium, and the lower jaw is articulated with the upper. The eyes have a tapetum lucidium. The inner margin of the eye pelvic fin in the male fish is grooved to constitute a clasper for the transmission of sperm, and these fishes are widely distributed in tropical and temperate waters. So the most famous we have got here, the blooded killer, the ones who inspired many stories, great white sharks. So we can see how nicely and how fascinating it has evolved to be the perfect predators. The great white shark is the most infamous killer of them all the sharks, and a hungry great white is a speedy hunter. It has a spectacular taste for warm-blooded meat and often targets mammals such as seals or dolphins. It matches their speed because it has special strips of muscle that generate its own body heat, while a clever system of blood vessels keep the heat trapped inside. So as we can see over here, it has got very sensitive snouts to detect electrical activity given off by prey. row of teeth behind main ones replace any that break off. And big jaw muscles give the great white shark one of the strongest bites of any shark. And the dorsal fin, which is here, helps to stop the shark from rolling when it swims. And this is actually a fact, a very fascinating fact. Great white sharks can detect a drop of blood in water up to 3 miles or 5 kilometers away. Super predators. Size, speed and strong jaw all make the great white shark one of the most fearsome predators alive today. Youngsters are prey on other fish, but bigger adults turn to sea mammals and sometimes attack humans, as well as living prey. Great white sharks have also been seen scavenging whale carcasses. This is a spotted stingray, or also known as ribbon-tailed stingray. It lives in it is actually a tropical fish, we can say, with blue spots that can be used to attract attention. But this ray uses them to disguise itself as well. When the ribbon-tailed stingray settles on the bottom of the reef, the spots make it tricky to see its outline in the dappled, sunlight. It waits patiently for some tasty meal to crawl by, so it can smother the prey with its pancake-shaped body and eat it. But step on its back and you get a sting. Stinging tail with a spine, and the pain will be excruciating. Eye horns. The eyes are prominent, sticking up from the ray's flat body. This allows the ray to keep watch over the sands for danger or food. So as I mentioned earlier, rays are actually flattened sharks. So as we can see over here right now, it's the stinging spines. The ray has actually 1 or 2 jagged spines along its tail that cause the sting, and these are sharp enough to inject a painful venom. So it has actually got rigid ends, and so once it goes in, it will be very hard to bring it out. But have you ever looked at the stingray and saw the spine? If you have gone anywhere out, or like sometimes in aquariums you can see them. Have you ever seen the spines up close?
No.
I have not seen.
So it actually, we can see it's basically something like a knife. So but the many fascinating thing is that instead of a knife, it has got the 2 sharp edges, and it's more like a porcupine spine, we can say. So once it goes in, it will be very hard to bring out, the same way as sea urchin spines as well. So as we know, the stingrays spend much of its time on the bottom. Even when we see in aquariums, they're always lying down. But also a graceful swimmer like other rays, its sides are massive, expanded to form wings, which can flap to fly through the water. And the next one, we have got the most feared predator, is the tiger shark, also known as the hunter in the dark. So, have you ever, seen a shark from near, a big shark, the small ones you see in the fish market, a big one up close?
Yes, I've seen it in the aquarium.
Dubai Mall.
In Dubai Mall Aquarium, we're actually seeing sand sharks, those with very, scary looking teeth, I think. But tiger sharks are actually not, although they are very famous sharks, they are mostly not kept in aquarium because they are, they never, they never, stop eating, we can say. So we can say few animals can match the tiger shark's appetite. Turtles, birds, other sharks, and even human beings, injured whales and old tin cans all get gobbled down if it gets the chance. This fierce predator prowls around shoreline at night, often venturing into estuaries and harbors in search of food. It is usually alone, and it is perfectly at home hunting in dark and murky waters. So it has got very, very powerful eyes. So it, of course, much more powerful than ours, because it can see like night as if it's day with exotic colors. The tiger shark has a sensitive layer at the back of its eye, that detects even the faintest amount of light. This enables it to snatch prey at night, even if the water is very, very cloudy. And you know, the way it stays afloat is that the tiger shark has a large liver that sits on top of its stomach and gut. The liver contains a lot of oil, which helps the shark float and stay buoyant when swimming. It also has a spiral valve in its gut that slows down the passage of food so that it can absorb as many nutrients as possible. And of course, the most famous thing about sharks is their teeth, because they're the cutting edge equipment. The tiger shark has especially large teeth. They curve slightly backward and each one has a sharp serrated edge, like that one of a saw, for cutting through skin and flesh. The tiger shark also has a reputation of eating anything it comes across. This strategy is useful when there is not much food around, but it also means that it sometimes swallows objects that it cannot digest. Like most sharks, it has a short gut, so bones and other hard material have to stay in the stomach much longer or be vomited back up. So, iconic pelagic shark species, or we can say the ones that live in the open ocean. The most famous is the largest fish in the world, the whale sharks. And we can all of us have heard about the oceanic white tip shark. I'll ask you a question. Will you be swimming with a great white, a tiger shark, or a whale shark? Which one do you prefer?
Can you repeat the question?
I'm saying if you had a chance to, for example, go diving, will you be swimming with a whale shark, a great white, a hammerhead, or we can say the tiger shark?
Great white.
Whale shark.
Great white.
Whale shark, exactly. Because if not only seeing the animal is important, but as I say always, you have to look at the animals from a safe distance. And great white sharks are the only animals which are very curious. They come close, they're like, is this person floating in the ocean food? Maybe it is. So let me take a bite then. That's why we use shark cages. I said only if you have a chance to dive without any cages. Because whale sharks are the largest shark, as I said, and indeed largest of any fish alive today. They have no harm because they don't have much of sharp teeth, and they don't actually present the modern shark we always imagine in our heads. They feed on plankton and travel large distances to find enough food to sustain their huge size. Whale sharks are found in all the tropical oceans of the world. Blue sharks, in the other hand, are one of the most common and widespread sharks. They are found in the open ocean and along the coasts of every continent except Antarctica. They undertake great migration to seek prey and reproduce. Blue sharks feed mostly on small fishes and squid, and will occasionally kill seabirds as well. The oceanic white-tip shark, with its round pectoral and dorsal fin and white tips, is a top predator of the open tropical oceans. It mostly feeds on bony fishes and squid, but it also eats turtles, stingrays, and even seabirds. Iconic reef sharks. I think, to my thing, they are the most important thing. The most important animal in a reef ecosystem, because they help to keep the fishes population in balance, so they won't eat too much algae that will harm the reef. And we have got three species here: white tip reef shark, grey reef shark, and tiger sharks. The most famous, as we know it, is the tiger shark. So white tip reef sharks are often found in caves and resting on the seabed by day, because most of the sharks, almost all of them, are actually nocturnal, and so they are widespread on reefs in tropical Indian and Pacific Oceans. These reef sharks occur from the surface to at least 300 meters deep. This species typically searches crevices by night, looking for octopi, crustaceans, and reef fishes that it feeds on. A common shark or coral reef is the coral triangle, or we can say the grey reef shark, mostly like that. Central Pacific and West Indian Ocean it's found in, and a strong swimming species that likes areas with high currents and well known to divers. The grey reef shark feeds mostly on bony reef fishes and also octopi, squid, and crustaceans. And tiger sharks. Tiger sharks grow to huge sizes, and as I mentioned here, one of the largest and most distinctive predatory sharks, growing to at least 5.5 meters. Tagged tiger sharks have undertaken long and often unpredictable migrations. This top predator occurs along the coasts of all the world's tropical seas. While found on reefs, this species also visits estuaries and other habitats in search of food. Prey includes other sharks, rays, turtles, bony fish, seabirds, and marine mammals, live or dead, doesn't matter. And now, so have you ever seen any of these species of stingrays up close? I think most of us have heard about manta rays.
I've heard about the bow-mouth guitarfish.
Okay, have you ever seen one?
These are the stingrays which killed Steve Irwin.
Not ma'am, like this one, but we can see the black blotched stingray, yes. But the bowhead guitarfish and the giant manta ray, they don't have the stinger. So the stingrays which have got the spine at the end of their tails, that's the most dangerous thing to look for, because like at any time we cannot expect if the animal feels threatened, just if it even injects the spine in any part of the body, and especially in the vulnerable parts such as the organs and all these things, then it will be fatal. But these two species, giant manta ray and the bowhead guitarfish, don't have stingers, but the black blotched stingray can have.
They can be their sting can be fatal, right?
Yes, and they can, even the small ones are really fatal, because like they have got very flexible tails that almost can turn 360 degrees from the tip of their thing. So once, for example, any human steps on it by mistake, because they go under sand, it's actually going to be very fatal. So because the time when it goes in, sometimes it doesn't come out very easily, and it injects very powerful venom as well.
Okay.
So giant manta rays are impressive, graceful creatures and the largest rays on the planet. Unlike many other rays, they do not lie on the seabed, but are able to swim continuously. They feed on plankton and undertake migrations across the open ocean and are widely distributed. In certain coastlines, giant manta rays are predictable seasonal visitors, arriving to be cleaned by reef fishes or aggregating in large numbers to feed or mate. Bow-mouth guitarfish, on the other hand, are an uncommon but distinctive species of ray occurring in tropical waters from East Africa to Australia and Japan. They are found along coastlines and on offshore reefs to depths of around 100 meters. Bowhead guitarfishes feed on crabs and large fishes, which they often eat whole. So we can say most of the time, except the giant manta ray which feeds on plankton, most of these stingrays actually feed on, for example, mollusks such as snails and clams. And the black blotched stingray is one of the largest stingrays found on tropical coral and rocky reefs in the Indian and Pacific Ocean and Red Sea. Black blotched stingrays are well known to reactional divers, and while normally found by itself, aggregations do form, probably for mating. So, early evidence of sharks. How did sharks evolve? The teeth of sharks are common fossils, and the first sharks lived about 380 million years ago in a sea that covered what is now Ohio. When they died, they sank so quickly into the silt on the seabed that their skeletons are well preserved. So this one right here is the spiral fossil teeth from a helicopterian. And its teeth in its upper and lower jaws, rather than it doesn't shed them at regular intervals, and the oldest teeth are in the middle of the styrol. So we can see the oldest teeth form over here. Helicopterian. Scientists are unsure exactly what helicopter looked like or fed on, since only its teeth have ever been found. This shark survived for nearly 100 million years but left no descendants. Its fossils are widespread throughout the world. Ancient sea dwellers, such as the Secundus, had a patch of large dermal denticles on its head and on its on its first dorsal fin. They may have been for protection or enabled it to latch onto other bigger fishes, just as the modern remora does. So what about fish evolution? Fishes have lived in the sea for nearly 500 million years. The first fish were jawless like lampreys. Modern fish appeared at the end of the age of dinosaurs, about 65 million years ago. Coelacanth and sturgeons have survived the extinction of most of their relatives. Sharks have been around for hundreds of millions of years, appearing in the fossil record before trees even existed. But what did they evolve from? Are they living fossils? And how did they survive 5 mass extinctions? Sharks belong to a group of creatures known as cartilaginous fish, because most of their skeleton is made from cartilage rather than bone, and the only part of their skeleton not made from this soft, flexible tissue is their teeth. The group includes the most famous animals such as whale sharks and great whites, but also all rays, skates, and little known chimeras, also known as ratfish, rabbitfish, or ghost sharks. When did sharks first appear? The earliest fossil evidence for sharks or their ancestors are a few scales dating to 450 million years ago, during the late Ordovician period. Analysis of living sharks, rays, and other chimeras suggests that by around 420 million years ago, the chimeras had already split from the rest of the group. And as there was no fossil of these animals from this period of time, this is based solely on the DNA and molecular evidence of modern sharks and chimeras. And it was also around this time that the first plants invaded the land. Oldest shark teeth. As we know that around the world, the most common fossils of any animal is shark teeth, and the earliest shark-like teeth had become, had come from an early Devonian, which is around 410 million years old, fossil belonging to an ancient fish called Doliedus problematicus, described as the least shark-like shark. It is also thought to have risen from within a group of fish known as spiny sharks. After a very short period of time, it was the golden age of sharks, the Carboniferous period, which began 359 million years ago, is known as the golden age of sharks. An extinction event at the end of the Devonian killed off at least 75% of all species on Earth, including many lineages of fish that once swarmed the oceans. This allowed sharks to dominate, giving rise to a whole variety of shapes and forms. Some of the most bizarre prehistoric sharks to appear during the time actually evolved out of the chimeral lineage. Has any of you actually ever, for example, discovered any shark teeth, any fossils you have got?
No, I didn't.
Where do you think, for example, are the most common fossils of sharks? For example, you can find shark teeth. Some of them are actually found on land, some of them are found in rivers, and usually in murky waters they are very common, mostly like the megalodon tooth. And what is the origin of sharks, which we call them fearsome jaws? The end of the Permian period, which was about 252 million years ago, saw yet another mass extinction event, wiping out around 96% of all marine life. But a handful of sharks' lineages persisted. By the early Jurassic period, which is 195 million years ago, the oldest known group of modern sharks, the six-gill sharks, had evolved. They were followed during the rest of the Jurassic by most modern shark groups. It was at this point that they evolved flexible, protruding jaws, allowing the animals to, you know, eat prey bigger than themselves, while also evolving the ability to swim faster. While again, another mass extinction wiped out most of the sharks, and so sharks started shrinking. At the end of, or we can say at the beginning of the Cretaceous period, 145 million to 66 million years ago, sharks were once again widely common and varied in the ancient seas, before experiencing their fifth mass extinction. Fossil teeth show that the asteroid strike at the end of the Cretaceous killed off many of the largest species of sharks. Only the smallest and the deep water species that fed primarily on fish survived. So we can say since the first sharks evolved, ways of life in the sea had changed very little. As a result, many of today's sharks are much like their ancient ancestors. Some are so similar that people think of them as living fossils. As such, they can tell us a great deal about animals that may have been extinct for many millions of years. So I've got many species here, old relatives, fossils of fish very similar to the Port Jackson up here, and monster mouths such as the megalodon. And it actually only takes imaginations to think how large these creatures were on that time. Why are fossil shark teeth so common? Can anybody tell me from their own perspective? The vast majority of shark fossils found are teeth. So why is that the point?
The sharks have more number of, right?
Yes, ma'am. Yeah.
So maybe, and that is why they are very strong, so that the material they are made up of last longer.
Yes, ma'am. They are very common because for two reasons. Because most of the skeletons of sharks is made from soft cartilage. It takes special conditions for this to preserve, but the teeth, however, are made from a much tougher material known as dentin, which is harder and denser even than bone. While this enables a powerful bite, it also increases the chance that the teeth will fossilize, as they are less likely to decompose. And the other reason is that the numbers of them, rather than having just a few sets of teeth that last all their life, sharks are continually producing new teeth. As an older one breaks or wears down, it simply falls out of the front or of the mouth and onto the sea floor, as new tooth takes its place. Depending on the species and diet, over its entire lifetime, a shark can produce between 20,000 and 40,000 teeth. This means that there is much greater chance that shark tooth will be preserved and turned into a fossil. Not only are the teeth the most common part of the sharks to be found, they are one of the most common fossils of any organism. Do you know what is this shark and why is it known for?
No.
Actually, they thought that this species had gone extinct a very long time. It's called over here the living fossil frilled shark. And as it is over here, looking more like a mythical sea snake than a shark, this deep sea monster belongs to a group of sharks whose beginnings stretch far back to the time of dinosaurs. The frilled shark is strange in many ways. Its spine is incomplete, so its back is supported by a rubbery rod, and it has 6 gill slits, whereas most sharks have 5. Its head looks as though it should belong to a lizard, and inside its wide jaw there are hundreds of 3-pronged needle-sharp teeth that can bite slippery squid. So the
Are they big like the normal sharks? Are they big like the normal sharks, or they are small in size?
Ma'am, they grow to large sizes, such as the ones which you mostly see in the fish markets, even larger than that, but mostly like size of, we can say, a moray eel,
Not like the ones we saw now, no? The white shark and all, not of that big size.
No, I'm not of that big size.
Okay.
Actually, ma'am, it grows to a maximum of 7 feet.
7 feet. Oh, okay.
So we can say that the frill shark's ancestry dates back to 150 million years ago.
Okay. So they're completely washed out, no? I mean, completely gone from.
Yeah,
this
no,
earth.
actually, their ancestors are completely gone. But then again, when they were rediscovered, they were called living fossils. They actually live in the deep oceans. So when they were caught and then again found like the silicate, they're called living fossils because like they represent they have not changed for a very long time since the times of the dinosaurs.
Okay.
So as we said again, the shark skeletons are different from other animals and humans because their skeletons contain a soft, flexible, gristly-like material called cartilage. And in some sharks, part of the skeleton is strengthened by calcium salts, particularly in the bones of the back, jaws, and brain case. So we have got hard cartilage, support skeletons. You can see even the fish skeletons, the quads, that's a quad fish, and it has a skeleton which is made of bone and is more complex than that of a shark. The jaws are different from a shark's. The gills are protected by a big plate of bone, and the fins can be folded against the body. And the rays also, as we can see, it has got something like a wing. So a raised skeleton is made entirely of cartilage and forms a framework for its wing-like pectoral fins, and has a large and powerful shoulder bones to take the stresses of swimming. And the bones of the pelvic fins are quite small. The most famous thing of any shark is their jaw and teeth. Their jaws are only loosely attached to their skull. When a shark bites its prey, the shark are forced forward, allowing the teeth to be used more efficiently. As we said, renewable teeth, the sharks keep on shedding their teeth, we can say, and growing new ones. While the basking sharks, which have the teeth like this, do not tear or crush. Their food is mostly plankton, so their teeth are small, resembling coarse sandpaper-like structures. This, however, is a Port Jackson
I heard there is
shark.
a shark with 7 rows of teeth.
Almost all sharks have many rows of teeth. I think that's the great white shark. There are actually many of them. Depends on the food they eat. If they keep on shedding, then those teeth will actually, because it keeps on curling backwards. Same like, for example, the common thing which you see in the Dubai Mall, the sand shark. Or they don't, they have got very scary teeth, but they hardly even come near to humans. So over here we can see the gills and the livers. A shark breathes by taking water into its mouth and pumping it over the gills that lie behind its head. As the water flows past, oxygen in it is removed and passes into the bloodstream to be used in the shark's body. The liver contains high quantities of oil that aid buoyancy, like the swim bladder of a bony fish, or as we mentioned earlier, the oil in the tiger shark's liver. And when the gills are shut, as we can see over here, the shark takes water into its mouth and the gill slits are closed. While when it's open, water and carbon dioxide waste are expelled when the gill slits are open. And we can see different organs of fish and sharks over here. And while we have got the basking shark, which was hunted for its oil in its liver. Again, sharks, the reason I asked you before that why they survived the 5 mass extinction is that they have got extraordinary senses, eyes, that they have got very powerful eyesight. Sharks can see well in dim lights. The rays have a layer of cells called a tapetum that reflects light back onto the retina. In bright light, they can close the pupil to a narrow slit, and some sharks have a light blocking screen to filter light. So here is a dogfish with closed pupils, here is a horn shark's pupil, and here we have got a ray eye with screen. And teeth, cutting edges. Variation in the teeth shapes of different species probably reflect the difference in the prey they are hunting, or the different hunting techniques. Sharks that feed on large fish or mammals usually have triangular teeth with serrated saw-like edges. Here we have got a great white shark's teeth, mako shark, tiger shark, and a lemon shark. Of course, not doesn't taste like lemon. Ask.
Is any shark nocturnal?
Almost all sharks are nocturnal, right? Because like most of the times they are nocturnal because like their prey is usually fishes. So when the fishes are hiding or like in the morning, because most fishes are out and they can easily see the sharks, and because sharks have not got that much powerful eyesight, they cannot hunt it easily. But at night, when the fishes are sleepy or hiding in different places, the shark can easily find them and eat them without them even sensing, because the fishes are actually sleeping. But again, we have got some sharks that are actually not they are not nocturnal, they are diurnal, but it also varies in the place they are living and the type of prey they hunt. So now, as we are in the senses, this is the most interesting part of this session, because sharks have got fascinating senses that when we think of it, it's beyond our imaginations. It is hard to imagine what the world look like when you have a wide eye view like the ones of a hammerhead shark. However, excellent vision is only one part of the hammerhead story. Its extraordinary head is also packed with sensors, and sweeping it from side to side helps the shark find prey. It may even be useful in helping the shark stay buoyant while swimming. So we can see over here, this is the olfactory sac. The large olfactory sac is excellent at picking up smell. Here we have got the optic nerve, which carries information about vision from the eye to the brain, and the spinal cord carries information between the brain and the rest of the body. And sharks have small hearts as well and low blood pressure, but swimming helps push blood around the body. So, multi-purpose hammer. The shape of the hammerhead may help it swim. Hammerheads are less buoyant than other sharks, but the hammer helps provide lift, just like an aircraft wing in the water. And it's got fascinating senses. As I said, a head for sense. All sharks have sensors in their head, but the hammerhead has more than most. Each blade of the hammer contains a large organ for smelling prey, and the skin is dotted with jelly-filled pores for detecting movement, which we are going to come to that in a while. Finding buried food. The shark sweeps its head from side to side like a metal detector, so that the front edge of its hammer picks up signals coming from its favorite buried prey, stingrays. However, there are some animals in the oceans, as we say, oceans are also very dangerous, which are actually poisonous or sometimes very deadly. One which I've got here is called the torpedo ray. The torpedo ray looks like a harmless flat fish, but it has a stunning secret weapon. Its fleshy body is packed with a pair of fat electrical organs that can fire a shock through the surrounding seawater. The ray uses its organs to electrocute its fishy predators, or fishy prey sometimes. But if provoked, it is more than willing to use them when danger of threat, such as sharks or other animals trying to attack it. The electric organs of the torpedo ray are under the direct control of the ray's brain. When the ray's spots an unsuspecting fish, it gently hovers over it before zapping it and with an electric shock. As it delivers the shock, the ray wraps itself around its victim and the stunned fish is then swallowed whole. So here we can see the kidney-shaped electrical organs. The pectoral fins are wing-like and surround the body to form a hat-like shape. Electric organs contain more than 500 jelly-filled batteries that can deliver an electric shock into the water. Nerves carry signals from brain to the electrical organs, and the first of the two small dorsal fins are here, and pelvic fins are much smaller than pectoral fins but can still flap to help it swim. Tail is shorter than body disc and provides some propulsion for swimming. We can say the torpedo ray is actually a very dangerous ray. The oceans, rivers is the least discovered area of our planet, and just imagine how many animals are there. Some of them, such as the electric ray, torpedo ray, can give shocks that can kill prey in an instant. Most animals don't have the ability to detect electric fields, and this is something that has fascinated me a lot while studying about sharks. But sharks and rays, skates and sawfish, members of the group called bronchi as we mentioned earlier, are masters of detecting electric signals. As we know, all of us give out electric signals from ourselves in different amounts, and it's one of their defining features. Elasmobranchs have specialized organs called ampullae of Lorenzini. These tiny structures allow them to home in on weak bioelectric fields generated by nearby prey. Animals emit low-frequency electric fields due to the process known as osmoregulation. This process allows the concentration of ions, charged atoms or molecules, to follow between the inside of our bodies and the outside. In order for our cells to stay intact, the flow of ions needs to be balanced. Elasmobranchs, electroreceptors, but it doesn't always need to be balanced. It varies. So we can see it's a raised back, and here we have got the canal and the pore as we mentioned earlier, and the dark spots are actually the ampullae, the electric receptors that help it to take electric signals from its given off by its prey, and it actually has those pores on the back as well to detect predators from approaching it. The same thing is with the shark. These tiny pores help it to detect signals, electrical signals from giving off by prey, and that's why sharks can, like we can say, it has a very fascinating sense and can even hunt in the murkiest of all waters. How does it work? Elasmobranch's electrosensory organs are named after a 17th century Italian physician called Stefano Lorenzini, who first identified them while dissecting an electric ray. Lorenzini noticed dozens of tiny pores around the animal's mouth. Each of the pores led to a jelly-filled canal that ended in pocket-like structures that he called ampullae, the Latin word for a type of round-bottomed flask. An experiment measured the low electric currents that animals generate and replicates those currents to understand how stingrays find their prey. By luring a stingray towards electrical pulses in a tank, we can measure the sensitivity and range of the stingray's ability to detect them. But balance doesn't always necessarily mean equal. As we said, balanced ions. The concentration of ions within, for example, a shrimp's body is much lower than that of a seawater it swims in. Their voltage or potential difference generated between the two concentrations across leaky surfaces can then be detected by the ampullae. Animals that hide on the seafloor are often masters of, disguise. But even the most evasive of prey cannot hide from hungry stingrays. These predators can detect tiny electrical currents radiating from animals like shrimp and small fishes. Without using their ears, nose or eyes, stingrays can locate and devour their prey. And most animals don't have the ability to detect electric fields, but sharks, rays and skates, as we mentioned earlier, are masters of detecting electric signals. It's one of their defining features. They have specialized organs called ampullae of Lorenzini that are these tiny structures which I showed you earlier that allow them to home on the weak by finding or detecting by electric fields generated by nearby prey. But exactly how does this electric sense work? The white plate seen on the left has electric dipoles distributed across its surface. For example, a fish breathes in and out about twice every second, generating a current of around 2 Hz. So what is the science behind this? Elasmobranch's electrosensory organs are named after a 17th century Italian physician, as we said, who dissected a ray. But each of the pores led to the jelly-like canals that ended in pocket-like structures that he called ampullae. And here we have got the skin of the ray or shark, and here we have got a pore. When the electrical energy is detected, the electricity actually passes through the canal and into the ampullae and is detected by the nerves over here and taken to the brain, and then it's generated that, for example, it's a fish, but it's a different animal, and of course it has a very fascinating power to know what prey actually it is. Electric fields travel through the rays, canals and into their ampullae, and the tiny hairs read the signals and send a message to the brain via a network of nerves. But what are weak bioelectric fields? Animals emit low frequency electric fields due to the process known as osmoregulation, as we said earlier. This process allows the concentration of ions to follow between the inside of our bodies and outside in order for our cells to stay intact and follow. But follow ions needs not to be balanced. But balance doesn't necessarily mean equal. As we said earlier, like for example, when a shrimp swims in the water, the shrimp's body is much lower, has a lower electric field, or gives a lower electricity current than the seawater it swims in. Their voltage or potential difference generated between the two concentrated across leaky surfaces can then be measured. So you can see over here, this is the way, for example, different animals emit the electricity, and it's detected by the pores on the ray's mouth, which usually finds its prey, and by, for example, at the time when it's being hunted by predators, it can also detect predators by the pores on its back as well. Now we have got a drawing. It's a great hammerhead shark. Thank you for joining this lesson. Hope you enjoyed, and make sure you click on that subscribe button, like and share, so we can reach a higher audience, and of course be able to reach more people and spread awareness and help them learn about the natural world. Be curious, love the natural world and protect it. Thank you for watching this video. If you like it, please give us a like, comment and also share. And don't forget to subscribe and hit on that bell icon so you can follow us through all our adventures and research.